Good morning. Today we are learning about quadratic equations. So let's get out your notebook. You'll take some notes and we'll do several examples. First, we want to discuss what a quadratic equation is. An example of a quadratic equation looks like this. Here you have the x term is squared. That's what makes it quadratic. Minus 3x plus 3, and you set it equal to 0. So this is a quadratic equation. It's a trinomial, and one of the x terms is squared. When you graph the quadratic, you'll get a nice curve like this, and this is called a parabola. And we'll discuss that a little bit more later. The name quadratic comes from quad, meaning square, because the variable, the x term, is squared, x squared. It is also called an equation of degree 2 because of the 2 on the x. So the highest degree that it has, or the highest exponent that it has, is a 2, so that's called a degree of 2. So the standard form of a quadratic function or equation looks like this. You have ax squared plus bx plus c, you've seen that before, equals 0. So you must add the equal 0 because now it's not just an expression, it's an equation. So a and b are the coefficients. A is the coefficient, b is the coefficient here, and c is your constant. And the only thing that you can't have is that a cannot be 0. So b could be 0, c could be 0, but a cannot be 0. X is what we're looking for. It's the variable or the unknown. And so when we solve a quadratic, we're looking for the value of the x term. Okay, here are some examples of what quadratics can look like. Here we have 2x squared plus 5x plus 3 equals 0. So a is 2, b is 5, and c is 3. Here is another one that is a quadratic because you have an x squared minus 3x, but you're missing the constant term. But that's okay because the constant term will be 0. And here the a is 1, b is negative 3, and c would be 0. This one, this last one, this is not a quadratic because you do not have an x squared term. In other words, a is equal to 0, which means it can't be quadratic. So we'll look at a few more. Remember, the standard form of a quadratic equation is ax squared plus bx plus c equals 0. Excuse me. But sometimes a quadratic equation doesn't look like that. So for example, here you have x squared equals 3x minus 1. Well, if we move all of the terms to the left-hand side, we would end up with x squared minus 3x plus 1, and then set it equal to 0, add that equals 0, and we have a quadratic equation. So this is a quadratic equation in disguise, as it says, where a is 1, b is negative 3, and c is 1. Here we have a quadratic equation, but all we have to do to make it in standard form is to expand, so multiply the 2 times everything, and then move that 5 over to the left, and you would end up with 2w squared minus 4w minus 5, and set it equal to 0. So then you have your coefficients, your a, b, and c. This is another example. This is a quadratic because if you multiply the z times the z, you get z squared, and the z times a negative 1, you get negative z, and then move the 3 to the left, and you have minus 3 equals 0. This one is also a quadratic equation. If you multiply everything by x squared, so x squared times 5, you get 5x squared. X squared times 1 over x, you would get x, and x squared times this last term, you would get negative 1. Set it equal to 0, so this is a quadratic equation as well. So now that you know what they look like, now we're going to solve. Now remember, these quadratics, well, nothing. We'll go over other stuff later. All right, let's get started on solving them. All right, so how to solve a quadratic. The solutions to the quadratic equation are where it is equal to 0. There are usually 2 solutions as shown in the graph that you saw. They are called roots or sometimes zeros. So the solutions to a quadratic are called roots or zeros. And what we're looking for is, if you have a quadratic like that equation, you're looking for, this is the x-axis right here, the x-axis, you're looking for where the quadratic crosses the x-axis, and those are called the roots or the zeros. There are three ways to factor the solutions. One, we factor the quadratic, and that's what we're going to do today. So we find out what to multiply them to make the quadratic equation. We're going to factor, which means we've done that before. Or we can complete the square, and we can also do the quadratic formula. So let's get started on factoring the quadratic. And again, what we're looking for is the zeros, where the parabola crosses the x-axis. So this is 13.1. The steps for solving a polynomial equation or a quadratic by factoring. First, we're going to isolate the zero. We're going to factor, and then we're going to set each factor equal to 0 and solve for the variable. Remember, the roots or the zeros, the solution is called the roots or the zeros, and these are going to be the x-intercepts of the parabola where it crosses the x-axis. So we're looking for the x-intercepts. Those are called the roots or the zeros. So example number 1, and you will see this on different tests. You have x plus 1 times x minus 3 equals 0. Well, your first step is to isolate 0. That means to have 0 on one side of the equation, and we have that already. Your second step is to factor. Well, these are two factors of a trinomial. So the third step is to set each one of these equal to 0. So what that means is I'm going to take each factor, so this is one factor over here, x plus 1, set it equal to 0, and then x minus 3, set that equal to 0. Now I solve for x, which is really easy. On this one I just subtract 1, so x is equal to -1. Here I add 3 to both sides, so x is equal to 3. So these are the solutions to the quadratic, which means on the x-axis, if you were to graph this, and I'm going to just show you, if where x is -1 right here would be a point where the parabola would cross, and where x is 1, 2, 3. So you would have a parabola that would look like this somewhat. This is not the exact drawing because there's some other information we need to know. But here's your parabola. These are called the roots or the zeros, the x-intercepts. All right, let's look at the next one. Now you have 2x minus 3 and 3x minus 4. So you already have your 0. These are the two factors. So you just set each of these equal to 0. So I'd set 2x minus 3 equal to 0, and I'd set 3x minus 4 equal to 0. Then I solve each of these for x. So I add 3 to both sides, and I'd get 2x equals 3, and then divide by 2. So this 0 is at x equals 3/2, which is also 1.5, 1.5. On this one, I do the same thing. I'm going to add 4 to both sides. So then when I do that, I get 3x is equal to 4. And then I would divide by 3. So my x over on this side would be 4/3, which is 1 1/3, or 1.3 repeating. So if you were to graph this, which you could, you would see that where x is 1.5, so this one's going to be kind of weird. So I'm going to do, there's 1, there's 2. So it would cross at x is 1.5 and x is 1 1/3. So you'd have this really skinny little parabola that went like that somehow. All right, let's do a few more. All right, so we're going to do example 3. Example 3, now this one looks a little bit different. We do have the 0 already, so you have to make sure you have a 0 on one side. And then you have to factor. So now I need to factor this to see what my zeros are going to be. So the first thing I would do is factor. So remember, we have to multiply A times C, and we're looking for factors of 6 that add to -7. So I could do 6 and 1, and since they would both have to be negative because they would need to add to -7. So then my factors would be, I'd have 2c squared, remember to bring that one down, and then we're going to break this into two factors, -6c, -1c plus 3. And then we're going to group, so I bring down my equal 0, so then I remember I group. And then I'm going to factor this out, so I'd have 2c, and then I'd be left with c minus 3. And then here I'm going to divide out a -c, remember because that, or not a -c, a -1, because that first term is negative, so I'd put -1 right here. And then I would factor and get c minus 3 equals 0. And now I'm going to group the 2c minus 1, so I get 2c minus 1, and then I get c minus 3. So now I have my trinomial factored. Now I'm going to set each of these equal to 0. 2c minus 1 equals 0. c minus 3 equals 0. So I solve for c, add 1. And I would get 2c equals 1, then divide by 2. And so c is equal to 1/2. On this one, all I have to do is add 3 to both sides, and at some point you'll do this mentally. So c is equal to 3. So my zeros, or my solution, is c equals to 3. And c is really x. So these are my x-intercepts. Okay, example number 4. Now, this one's a little bit different. You can see that you have some numbers, but there's no 0. And so what we need to do is get it into the standard form, which means I need it to look like this: ax squared plus bx plus c equals 0. That's standard form. So if I just subtract 2 from both sides, then I would end up with standard form, which is -5b squared plus 7b minus 2 equals 0. And that's standard form. So now I have the quadratic equation. I just need to factor it now. So I'm looking for, I have to multiply -5 times -2. So I'm looking for factors of 10. And they need to add to my middle term, which is 7. So I know that I could do 2 and 5, right? 2 times 5 makes 10. And 1 is negative and 1 is positive. Ooh, that's not going to work because I can't get 7 with that. So I need to think of what I could get, multiply 10 by, to get 7. Okay, so it looks like this particular quadratic equation will not factor the traditional way, because the only factors that we can come up with are 2 and 5 and 10 and 1, and there's no way we can get those to add to a positive 7 when they would have to be negative times a negative and a negative times a negative. So this we would use the quadratic formula for. So we're going to table this. That means we're going to just pause on this one, and we can use this at a later date. So this is factorable, but when it doesn't factor the traditional way that you've been taught, you need to use the quadratic formula. All right, so let's go on to some other types of problems that you will see. So you'll see an example like number 5. This is a quadratic equation. It's equal to 0. It has an x squared, and then it has an x. So what we have here is it's not in the traditional form. So we need to see, remember the first thing we need to do when we factor is you want to find the GCF. And if I look at this, I can see that it has a GCF. It has a greatest common factor. So what we're going to do is divide out a 9 and an x. So when I divide out a 9 and an x, it becomes part of my answer. So I get 9x, and then I'm left with an x minus 2. Now, this doesn't look like what you're used to, but it's still a quadratic, and you still have two factors. You have 9x, so we're going to let 9x equal 0, and then we're going to let x minus 2 equal to 0. Well, over on the left, when I solve that and I divide by 9, you can see that x is equal to 0 divided by 9, which is just 0. That means that my x-intercept, one of them, is going to be where x is equal to 0, so it's going to be at the origin. Here I would add 2 to both sides, so then my x-intercept would be 2. So my parabola would actually go through the origin and then also at 2. So my two intercepts would be like that. And this is common to have an x-intercept as 0. All right, let's look at example 6. Remember, you want to make it look like ax squared. So ax squared plus bx plus c equal to 0. Now this one, we're going to subtract 32 from both sides. So I'd have 8p squared minus 32 equal to 0. So I'm missing that middle term. So over on this one, I was missing the last term, the c part, and on this one, I'm missing the bx. But that's okay, because remember in the beginning, the only one that can't be 0 is this one in the front. This one can't be 0, but the others can. So this is a perfectly acceptable format for a quadratic. All right, so what I want to do is I want to see, is there a GCF? So if there's a GCF, I'm going to factor that out. And I do have a GCF. My GCF is 8. I can factor out an 8 from both of these. So when I factor out the 8, it becomes part of my answer in front. So I have 8, and then I'd have p squared minus 4 equals 0. Well, what I recognize here is, yes, I have an 8, and then I have this. Well, this is called the difference of squares, dots. Remember, we learned about this. So I can keep factoring this, because this is a perfect square, that's a perfect square, and we have a minus sign. So I'm going to have an 8, and then I take a p and a p, and then what is the square root of 4 is 2. So remember, I put a plus 2 and a minus 2. So now I have 3 different factors that multiply to get this polynomial. So I'm going to set each factor equal to 0. So this is kind of weird, but I'm going to set 8 equal to 0. Well, does 8 equal 0? No, it does not. So this cannot be a solution. So it just kind of goes away. Then I would set p plus 2 equal to 0 and p minus 2 equal to 0. So I would subtract 2 from both sides, and I get p equals negative 2. Here I would add 2, so I would get p is equal to positive 2. So my parabola would look like this. I would have, this is p or x, this is p, and there's my y. So I don't know why they use all these weird variables, they just do. So p is equal to negative 2. So I would put a dot, that's my x-intercept, and then p is equal to positive 2. It's my other intercept, and then my parabola would look something like that. Okay, let's do some more. All right, these are the last two. So now I have a weird looking situation. I've got m squared plus 10 equals 10m minus 11. Now I know this is a quadratic because I have this x squared right here. So all I need to do is put it in the right form. So I'm going to move everything to the left and set it equal to 0. So if I subtract 10m from both sides, and then I would add 11 to both sides. I'll just do it one at a time. So subtract 10m, so I'd have m squared, I'm going to subtract it here, m squared minus 10m now, plus 10. I'm just going to put it in the middle because I want that m in the middle, equals a negative 11. So then if I add 11 to both sides, now I would have m squared minus 10m plus 21, and then I have to have it equal to 0. And now I can just factor. So I'm looking for factors of 21 that would add to 10. So I could have 21 and 1, and then I could have 3 and 7, right? 3 times 7, that makes 21. It also adds to 10, but they would both need to be negative. So I could factor this. I just put my m, I do m minus 3, and I do the shortcut method because my a value is 1 right here. My a is 1, so I can do the shortcut. So now I have my two factors. Then I set each one equal to 0, and then I would solve, x minus 7 equals 0. Then all I have to do is add to this side, so I get m equals 3, add 7 to this side, and I get m equals 7. So my parabola, these are my solutions, they're also called my roots, they're also my x-intercepts. And those are my answers. Let's do the last one, example 8. Now this one's definitely different because you've got the y squared on the right-hand side, and you've got the 5y on the left-hand side. So what I would do is now this is going to be strange, but instead of putting the 0 on the left, I'm just going to put the 0 on the right, because I don't want my leading term to be negative. So if I subtract 5y from both sides, my 0 would be over here, and I'd have 25y squared minus 5y. Now, if you don't like that, you can always switch these around and put the 0 on that side and put this on the other side. All right, now look and see. I have what? I have a GCF, right? Because they both have a y, and they both have a 5 that they can factor out. So I'm going to factor out a 5y. So I have 0 equals, and again, you can switch this to the other side, and I'm going to divide out a 5y, and that becomes part of my answer. And then 25 divided by 5 is 5, and then I still have a y, and then this cancels out to make 1. So this is equal to 0. These are my two factors. So I set each one of these equal to 0. So I take the 5y and make that equal to 0, and then I do 5y minus 1, set that equal to 0. Well, over here, if I divide by 5, I'm just going to get 0. So y is 0, which is fine. That's the origin. And then 5y minus 1, so plus 1 plus 1. Now remember, even though it says y, this is the x-intercept. So 5y equals 1, and then divide by 5. So I get y equals 1/5. And even though these are y, these are the x-intercepts, so if I were to graph this, I would graph it, because these are the solutions. So, and one of the solutions is here, and then one of the solutions, let's say if this was 1, would be about right here, 1/5. And so you would have a parabola, a skinny parabola that looks like that. All right, we're done for today. I'm sorry it's a little bit long, but it was necessary. So, have a great day.